Hello everyone. Previous electrophilic substitution reaction of phenol was a name reaction Reimer-tiemann reaction. In that one, we have done first type of Reimer-tiemann reaction. In this video, we will understand second type of Reimer-tiemann reaction. Topic is involved in 12th JEE NEET. Let's check. Only one difference is there. In previous Reimer-tiemann reaction, we have used chloroform. Here you don't have to use chloroform. At the place of chloroform, you have to use CCl4, carbon tetrachloride. This is the change only. Rest reagent, sodium hydroxide again. Carbon tetrachloride is a colorless liquid. Sodium hydroxide solid, white pellets you have to use. And phenol, you know, colorless crystalline solid it is. Heat these three chemicals up to 340 Kelvin temperature. First here, this compound will be generated. On a benzene ring, carboxylic functional group will be added and hydrogen of carboxylic functional group will be replaced by sodium. This compound is known as disodium salicylate. It's a white color, needle shaped crystal. Further acidification you have to perform with dilute HCl, means this white color substance which is generated here, you need to treat it with dilute HCl, we call it acidification. Due to acidification, you know what will happen, the sodium will be replaced by hydrogen. Both sodiums will be replaced by hydrogen. This COO, if bonding I talk, bonding is like this. This one. In mechanism we will discuss. Now the compound which is generated here, the common name is salicylic acid. Only this is the difference between first type of Reimer-tiemann reaction and second type of Reimer-tiemann reaction. If you are using chloroform, salicylaldehyde was generated, and if you are using carbon tetrachloride, salicylic acid will be generated. Very, very important. What is the physical appearance? It's a white crystalline solid. White crystalline solid. If I talk about IUPAC naming, out of carboxylic group and alcoholic group, carboxylic will work as a main functional group, so priority will be given to it 1, 2. OH will work as a side functional group. So when OH is working as a side functional group, we call it hydroxy. So the name will be 2-hydroxy benzene and carboxylic functional group, combinedly known as benzoic acid. 2-hydroxy benzoic acid, or you can call it, because this is ortho position, ortho hydroxy benzoic acid. This one. So ortho hydroxy benzoic acid you can call, 2-hydroxy you can call, salicylic acid you can call. Mostly this common name is used. Salicylic acid, salicylaldehyde, they are known with their common name mostly. Okay. One more important point. Para-hydroxy benzoic acid is also possible, this one. Para-hydroxy benzoic acid. But the problem is, this compound is minor. And this is major. Reason? Because this compound is getting extra stability. How? This hydrogen we know partial positive it is, this oxygen is partial negative. So between them we have a force of attraction which is providing extra stability to it, and that force of attraction is known as intramolecular hydrogen bonding, which is not possible here because OH and COH are far away from each other. And this bonding is also known as chelation. So this chelation or intramolecular hydrogen bonding is providing extra stability. That's why it is a major product. Now let's directly go for its mechanism. Very easy mechanism. Let's start. The phenol which you are using, in this phenol, the benzene ring is a high source of electron, and electrons are mostly present on ortho and para position due to resonance of oxygen, as we have discussed in the previous videos. Now these positions, ortho and para positions, can be attacked by electrophiles. Who is electrophile here? Let's check. Carbon tetrachloride. In carbon tetrachloride, you can check carbon is surrounded by 4 highly electronegative atoms. Chlorine. Chlorine electronegativity is more than carbon. So obviously, these electrons are shifted strongly toward chlorine, due to which, because you can check carbon is losing its electron, 1, 2, 3, 4. These 4 electrons are going toward all 4 chlorines. So this carbon will carry partial plus 4 charge. That's it. This partial plus 4 charge will make this carbon to attack on a benzene ring, because benzene ring is a high source of electron, means negative field, and this carbon is a positive particle, positive, negative, that's it. And which position? Ortho position. Para can also be attacked, but ortho is major. I have discussed it with you. Okay. Now, as it will attack on it, obviously, this carbon can't make 5 bonds. The old bond will break. Let's break old bond. Between chlorine and carbon, bond will break. Electrons will completely shift toward chlorine, because chlorine electronegativity is more. And when it will break bond from carbon, a vacant orbital will start to generate there, like this. With the help of this vacant orbital, it will attack on this carbon. And for bond formation, 2 electrons are required. This carbon do not have electron. So the responsibility of providing electron will be of this carbon. How it will provide electrons? By shifting these pi electrons here. With the help of these pi electrons, it will make dative bond with this carbon. And please keep in your mind here, hydrogen is always there. Okay. So when it will perform this action, the next condition will be, okay, first let's remove this Cl. When Cl will be removed, it will remove with -1 charge, because 1 electron of carbon it got extra. So Cl negative will be there. These pi electrons will make dative bond with this carbon. So let's make a dative bond. These 2 electrons, 1 electron will completely transfer to this carbon. 1 electron, this carbon will keep with itself. This electron is of this carbon, it will remain with it. Now this carbon, who has lost its electron, will turns to positively charged carbocation. Rest molecule as it is, no change. This one. The intermediate which is generated here, arenium ion, we call it arenium ion or sigma complex. Or simply you can call it carbocation. This step is always a slow step, because during this step the benzene ring is losing its aromaticity or stability. Okay, one more side by side reaction. Let me tell you what is happening here. This hydrogen, you know, it's a positively charged hydrogen. This one means this hydrogen is an acidic hydrogen, and you know the reaction is being carried out in base NaOH. OH negative, Na positive. So side by side acid base reaction you also need to write here. So OH negative will attack on this H and bond will break, and both electrons will transfer completely toward oxygen. So oxygen will become -1 charged oxygen, which will be satisfied by the sodium. So here this you need to write. And what will release out? H2O will be released out. This one. Now, this compound, this arenium ion is unstable. Many a time I told you, this carbocation was generated by this carbon, so it will bring its stability back. How? This carbon will break bond from its hydrogen and will fit these electrons here for the bond formation. Double bond will generate with the release of H positive. This hydrogen will be released as H positive with a vacant orbital. So let's make it. Here double bond will come, and rest molecule I am going to write as it is. Between sodium and oxygen, ionic bond will be there. As it is, this one. If I talk about this carbon, what kind of charge will be here on this carbon? No charge, because one electron was gone with chlorine, so it will become +1. But at the same time, it got one electron from here. Look here. So its charge will be neutralized. Right now it is in a zero charged form. This compound is generated. Now, second step, what will happen? You know, still it is present in basic medium, NaOH. These Cls which we are using here are negatively charged. Cl negative, Cl negative, Cl negative. All these Cl negatives will be replaced by OH negatives, because NaCl, Na is carrying positive charge, OH is carrying negative charge. So this Na positive will combine with the Cl negative 3 times. So 3 NaOH will be utilized, and you can check 3 NaCls will be removed out. Nucleophilic substitution reaction is happening here. So when you will replace all the 3 chlorines by OH group, so here we will have 3 OH like this one. Please check. Simple. Carbon is an electrophile attacking on ortho position. This one, this up to here you know how to join them. Hydrogen of phenol is also acidic, base is present, acid-base reaction. This one, sodium will be joined. It will get its stability back by breaking bond from hydrogen. H positive ion will be released out. This one. This compound which is generated is still in basic medium. So NaOH and this Cl will show substitution reaction. Na positive, Cl negative, and at the place of Cl negative, OH will be joined. And between carbon and chlorine, how bond is breaking? Obviously electrons are transferred toward chlorine side. So chlorine will get one extra electron every chlorine, so 3 Cl negatives will generate, because they are carrying one extra electron of carbon. Now because carbon has lost one electron, so 3 vacant orbitals will be generated, which will be satisfied by OH negative, 3 OH negative, because in OH negative you know oxygen is carrying extra lone pair. So every OH will donate its lone pair in vacant orbital of carbon, and 3 OH will make dative bond with this carbon like this. Due to dative bond formation, the 3 positive charge of carbon will be finished, because every time it will get one electron toward itself. So its positive charge will finish, and OH negative charge will finish, because every oxygen has delivered 1 electron completely toward carbon. So this compound will be generated. Now what will happen next? Check. Very easy. Many a time I have told you. Whenever on carbon we have 2 OH groups, it will become highly unstable. But here we have 3, so definitely lot of steric hindrance is there. So what will removed out? Water molecule. How? Look, out of these 3 OH, 1 OH will break bond from carbon, and obviously electrons will transfer toward oxygen side, because oxygen is more electronegative. Side by side, 1 OH will break bond from its hydrogen. So from here there is a release of H positive, and from here there is a release of OH negative. OH negative, H positive will combine to produce H2O as a side product. And what about this? this oxygen after breaking bond from hydrogen will become this, and this carbon after breaking bond from oxygen will have a vacant orbital like this. Now vacant orbital, lone pair, extra lone pair on oxygen will satisfy each other, and we will have C double bond O, OH with us, COH group. Out of 3 lone pairs, 1 lone pair it will use to make double bond with this carbon. Positive charge of carbon will finish because 1 electron oxygen will transfer completely toward carbon. So its positive charge is finished and its negative charge is finished. 1 electron it will keep with itself. This one. This compound is generated. Still we know this hydrogen is acidic. Carboxylic hydrogen. Acidic hydrogen. Medium is base. So again, acid base reaction will happen. OH negative, H positive. Between oxygen and hydrogen bond will break. Electrons obviously will transfer toward oxygen. H2 will release out. Because this oxygen will get extra electron of hydrogen, so this oxygen will become completely negative. Like this, which will be satisfied by sodium, Na positive. So finally we will get this one, disodium salicylate. Disodium salicylate. After getting disodium salicylate, the final step, you know, we have done acidification. This is disodium salicylate, which is generated at last, and then finally we need to proceed with acidification. We need to combine this white color powder into dilute HCl. You know, dilute HCl will provide us what? H positive, Cl negative. So here Na positive, they will combine with Cl negative. For balancing, 2 particles of HCl will be utilized. Na positive, Cl negative, they will combine. Na positive, Cl negative, they will combine. And at the place of Na positive, H positive will come. Between oxygen and hydrogen, dative bond will generate. It have a vacant orbital, it have a lone pair, so they will make dative bond with H positives like this. And because during dative bond formation, 1 electron, this oxygen will completely transfer toward hydrogen, so its negative charge will finish, and after getting 1 electron completely toward itself, the hydrogen's positive charge will finish. 1 electron it will keep it with itself. OH is generated. Similarly here, dative bond between this oxygen and this hydrogen. Charges will finish. The compound generated will be stabilized by intramolecular hydrogen bonding, because this oxygen is more electronegative than carbon, so obviously some electrons are more toward oxygen side, negative charge -2, and this oxygen is bringing electrons toward itself, so this hydrogen is positively charged, partially positive. So intramolecular hydrogen bonding is generated. This compound is generated, is known as salicylic acid or orthohydroxybenzoic acid. That's it. This is the mechanism of Reimer-Tiemann reaction, second type, where you are using carbon tetrachloride. So if I sum it up, so finally, if in exam condition is given this one, CHCl3, NaOH, and third condition acid, H positive, acidification. So when chloroform is used, the compound will be this salicylaldehyde, directly names they can ask. And if phenol is treated with CCl4, sodium hydroxide, and third acid. Sometimes they can write it like this also, H3O positive, so don't get confused. This one. So here you need to add carboxylic functional group, salicylic acid will be the major products. Very, very important reaction बच्चे. Mechanisms we have discussed and direct methods we have discussed. Thank you very much for watching the video.